Hi, I'm Hyunsung from Carnegie Mellon University. Today I present our work on evaluating dynamic delivery of audio and visual message notifications in extended reality. This research was conducted with Edgar from the University of Glasgow, David Lindlbauer, and Joseph O'Hagan. In this study, we evaluated 9 audio and visual notification designs for XR environments. We focused on response time, usability, general preferences, and how preferences change with different contexts. In spatial XR interfaces, notifications guide attention to important elements even outside the visual field. In this scenario, the user browses movies while keeping track of message conversations behind them. New message notifications are delivered both visually and auditorily, maintaining awareness without disruption. XR notifications must be informative but not disruptive. They need to provide timely, relevant information without breaking immersion or causing cognitive overload. An effective system gently guides attention without overwhelming the user. Previous work on message notifications for smartphones and desktops identified key factors like urgency, importance, message sender identity, and current task. These factors influence design decisions such as visibility, timing, modality, and prioritization. However, XR introduces new spatial factors like spatial relationships, spatial attention, environmental awareness, and immersion level. These factors require different design considerations, including spatial placement, modality for spatial cues, blending with the environment, and semantic alignment. These factors and decisions together shape the overall user experience in XR notifications, balancing informativeness and disruption. Rizariev et al. Studied the effect of notification placement in VR, showing that head-up displays are most noticeable and intrusive, while in-situ notifications are least noticeable but less intrusive. Our work extends this knowledge by considering audio notifications as well as visual ones. We focus on message notifications in XR, considering scenarios where users have messaging applications in their periphery, as in the previous video. Note that this messaging window itself is similar to the in-situ notification in Rizariev et al. In our work, we investigate different visual and audio notification designs. Our research questions are: how do different audio-visual XR notification designs affect response time, usability, and preferences in XR environments? And how do these preferences change in varying contextual factors of the message content, such as urgency and task engagement? Here we introduce our audio-visual notification design elements. On the audio side, designs vary from no audio to a simple ping to detailed speech cues.
Text from Thomas. Hey, are we still on for dinner tonight at 7?
Visual designs range from no visual to icons to full text messages. Combining these audio and visual designs creates 9 unique notification strategies. Each design offers a different balance of detail and modality. These designs allow us to systematically test how varying levels of detail in audio and visual channels impact user experience and performance. Participants performed 2 tasks simultaneously to simulate real-world multitasking scenarios in XR. The primary task was a fixed reciprocal tapping task in augmented reality. Participants had to select targets stated by audio cues, using the right controller to select the target and verbally confirming the color. The secondary task involved responding to message notifications. Participants had to press a button on the left controller based on the action indicated in the message. Here is a demonstration of the study task.
1, 12, 7, 6, 9, 6, 4.
During the experiment, we collected data on response times. Participants gave usability ratings after each condition, and after all conditions, they ranked the 9 designs on general preferences, frustration, and noticeability. Additionally, participants completed a survey on preferences of notification designs in various scenarios and message contents. The message contents consisted of higher urgency messages like hospital emergency and lower urgency messages like casual birthday messages. And here are some key results. Audio and visual cues significantly reduced response times compared to the no visual, no audio condition, which is comparable to the in situ notifications. Also, more detailed audio reduced response times when the visual was less detailed than audio. For example, when text notification was presented, there was no significant difference among no audio, ping, and speech notifications. And similarly, more detailed visuals reduced response times only when audio was less detailed. When speech notification was presented, there was no significant difference between no visual, icon, and text notifications. In other words, redundancy of level of details in audio and visual is not beneficial in terms of response time. This highlights the importance of balancing detail without overloading the user. In the rankings, the text and ping combination was generally preferred by participants, also showing least frustration and second highest noticeability. When we looked at preferences across different message contents, for higher urgency messages, participants preferred more noticeable notifications such as text-to-speech or text ping. It's also interesting to note that while redundant details in the audio and visual channels had no impact on response time, participants valued the redundancy for ensuring noticeability even if one modality is masked by environment noise or others. For lower urgency messages, preferences were more varied, indicating a need for personalized or adaptive notification strategies. In summary, our results show that the effectiveness of notifications depends heavily on the combination of audio and visual modalities. Pairing no visual elements, which is similar to in situ notifications, with audio elements significantly improves noticeability and response time. We also found that redundant level of details in both modalities do not affect response time, but are beneficial when a modality might be masked. Finally, varying preferences based on message urgency and task engagement highlight the need for context-aware, adaptive, and personalized notification systems. These results call for future work on notifications in XR beyond message notifications. For example, notifications can provide subtle cues for bystander presence when someone enters the user's physical space. This can help maintain awareness of the environment without breaking immersion. Audio and visual notifications can also guide users through tasks like shopping or cooking. For example, highlighting product locations in a supermarket or notifying when cooking timers are done. Notifications are also crucial in navigation, for example, providing turn-by-turn directions, helping users stay oriented without needing to check a phone or map. Lastly, notifications are used to provide timely instructions in AR for complex tasks, such as assembly or cooking. And our results inform the development of adaptive multimodal notification systems that can support diverse needs from safety and guidance to information delivery, which will enhance both productivity and user experience in XR environments. Thank you for watching. Please visit our website for more information.